Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm all right, thank you. How are you?
Very good, very good. So, how is your math preparation going on?
Good. Yeah. Just kind of doing exam questions related to those, topics. Finding questions from past papers. Like when we were revising and learning the content, you asked me to like look through actual papers and then find the actual questions related to certain topics. So I
Yeah,
compiled some of those onto a document. So I'm just going through them and then checking the answers and honestly, this look cover check thing. So yeah.
very good. That's good. Yeah. So, if you do subject wise, it is better. Normally, the exam papers are available year wise. So, every year there is
Oh,
so many different, but when we are preparing for an exam, one way could be we could compile the questions on each topic and then do topic wise first and then tackle it the other way, right?
right.
That
Yeah.
way we get the width and as well as the depth, right? So today we'll look into the depth of one particular topic. So which topic have you for me today?
Selected. So I chose trigonometry. I know it's a
Okay.
classic, but it's quite heavy in the marks. So yeah, I'll
Here,
be
sure. We'll go through the solutions quickly.
okay. I don't think we need to do all of them. I mean, if we see some that are kind of similar, we
Yeah,
can.
of course, of
Yeah.
course. Yeah.
Should we
So
start?
yeah, we can start with the very first one. What is that question says? Can you please read the question?
Yeah. So in the triangle ABC, AB is 11 centimeters, BC is 7 centimeters, and CA is 8 centimeters. Part A, find the size of angle C, giving your answer in radians to three significant figures.
Okay, so I'm just drawing a triangle at random, right? ABC.
Mhm.
I know AB is longer than the other sides, B to C, but I'm not making it to the scale, okay? So we just
Yeah.
have one triangle. So when we are given three sides of a triangle, then to solve this triangle, you will use cosine law, correct? That is first thing which
Yep.
come to your mind, correct? So cosine law is used in two cases. Can you tell me which two cases you will use cosine law?
So to find the angle and the side.
So the two cases are when you are given the three sides, not an angle, but if you're given
Yeah.
two sides and an angle
And an angle.
included. So in this two cases, we will use cosine law to solve any triangle. So remember that part, right?
Okay.
Okay, now what are they asking for? So as soon as you read the question, it should come in your mind. You will be using cosine law. You get my idea? That
Yeah.
is how
Yeah.
we have to read the question. Find the size of angle C. So let's mark this angle C. Giving your answer to three significant figures. Well, cosine law, we can directly find this angle C, right? Do you remember the formula? So let's write
Yeah.
down the formula first. So one formula will be AB squared.
Cos A.
So we are looking at the opposite side. So which is 11. So forget about ABC. You could have written A anywhere. When you have
Yeah.
the diagram, you want that angle, right? So when you want that angle, then the opposite side is what you're related in, right? So you'll say
Right.
11 square equals to 8 square plus 7 square minus 2 times 8 times 7 times cos of angle C, correct? So straight away you get the formula. You're looking at the angle of interest and the side opposite to it. Well, this formula, many students should remember, especially you, that it could be directly written as cos C equals to product sum of these two squares, which is 8 square plus 7 square minus 11 square divided by 2 times 8 times 7. Is that clear to you?
Yeah.
So you get the angle C by finding the cos inverse. So you could directly get to this step if you remember these formulas, not difficult to find, remember them, of course. And now look at the question. We want the angle in radians, three significant figures. So convert your calculator to radians measurement and then
Mm,
find the angle C, right? So C is equals to cos inverse of all this, which is 8 square plus 7 square minus 11 square over 2 times 8 times 7, right? So you can do this calculation and write down your answer. Right? So that's not difficult. Just take a calculator and plug it in and put it in, yes, put it in radians and tell me what answer
I
do you
got
get?
So it says to 3 significant figures, so 1.64.
Perfect. So that becomes in radians. You need not write RAD or radians, right? You need not write radian is a ratio. So even if you write 1.64, it is assumed to be in radian. It is a default unit for trigonometry, correct?
Oh,
So
even if they don't say in radians, it's just the default.
It's a default. No, when they say radians, you're writing 1.64.
Yeah.
Normally you write 1.64 radians, right? But in case you miss writing radians, I think marks should not be deducted because that is the default unit. For degree, you have to write degree. Is that okay?
Yeah, clear.
Important. So you will learn what to apply and how to do it. Part B.
Yes.
Say, what is part B? Brief.
So find the area of the triangle ABC, giving your answer in centimeters squared to 3 significant figures.
Okay, so what is the area formula for the triangle?
Half AB sine C.
So basically, whatever angle is given to you, we are looking at the angle given, right? So that becomes the included angle, right? Mm-hmm. And the two sides, SAS case. So we are actually looking at SAS case. Do you understand?
Yeah.
Side angle side. So those are the two sides of our interest when we use angle sine C formula, right? So that equals to half of 8 times 7 times sine of the angle, which we just found, which is 1.64. Use more digits. You rounded this number, right?
Yeah.
But use 4 decimal places to find the exact value and then round that.
That's what I was going to ask you, because I've seen questions where, so let's say you got the part A and you wrote an answer, but you had to round it. Sometimes in the answer, they use that value which was rounded, but I never do that. I always use the value, like the really long one, and then do it. So do you suggest to do that? Okay.
See, this value is still in your calculator. You get my point? This value
is so there's no harm in
you just the sine of this and then multiply with those things divided by 2.
Right. So let's so sine of that times 8 times 7 times 0.5 to 3SF, so 27.9 centimeters squared. Yeah.
Good job. So units have to be included. If they do not give you any units, just write unit square. Is that clear to you? Very important for area especially. You have to write unit square. So this is the revision of what is cosine law and how do we use it to find area of triangle, right? So we done the first question. 6 more. Can you please go through question number 2 now?
Yep. So, looks a bit more lengthy. Let's zoom out. Okay. Figure 1 shows a sketch of a design for a scraper blade. The blade AOBCDA consists of an isosceles triangle COD joined along its equal sides to sectors OBC and ODA of a circle with center O and radius 8 centimeters. Angles AOD and BOC are equal. AOB is a straight line and is parallel to the line DC. DC has a length of 7 centimeters. Part A, show that the angle COD is 0.906 radians, corrected 3SF. So COD, yeah.
So as you read the question, label, provide all the missing information in the figure as I was doing while you were reading, correct? So automatically that should come, right? Because time is very precious. So as you read, just plug in those values.
Right.
So we have an isosceles triangle DOC and the radius was 8 and therefore I put 8 there. You need to find the angle in between. What will you do? Cosine law straight, right? So we can now say that cos of this angle, let me say this angle is theta, is equal to 8 square plus 8 square minus 7 square divided by 2 times 8 times 8. Does it make sense to you? Right? So we can now get the value of theta as cos inverse of all this. Perfect?
Yeah.
So what do you get? Well, you have to get 0 point, nothing else, but 0.906, correct? What do you get?
Yeah. Oh, yeah. 2 times 8 times 8. Forgot the answer was given. Yeah. 0.9056. So when you round it to 3SF, yeah, so 0.906.
Write on 0.9056 because we are going to use this value to
Oh,
use
later on.
calculations, correct? That's very important, right? To be
Yeah.
precise, to be precise.
Yeah.
Now, remember, good idea to check. So that's what I like about your test papers. They give you the hint and they help you get the right answer. Is that clear?
Yeah. Yeah.
Very good. Next part. What is part B?
So part B is find the perimeter of A, O, B, C, D, A, giving
Everything.
your answer to 3SF.
Correct. So this arc is equal to that arc. So arc is, what is the arc CB equals to? R theta, right?
R theta, yeah.
8 times the angle. So what is this angle? You found 0.906, right? So this angle is 180. Oh, sorry.
Pi.
Pi, sorry. Okay.
Yeah.
So it's a pi minus 0.9056 I'm using, correct? Better value to use. Then I'm dividing by 2. So
yeah.
when I divide by 2, I get this angle. Is that okay?
Yeah.
R theta is this arc length. And we know that both are equal, right? So
you just need to find one and then times 2.
So I'll multiply this by 2 and also this by 2. Is it okay? So then this 2 and 2 will cancel.
Yeah.
And then do your calculation, write down your answer. So we got both the arcs.
Should I calculate it?
Yeah, yeah.
Oh, okay. So pi minus 0.9. So it's that value times 8.
Yeah, yeah, because both the arcs. So we are just calculating both arcs.
And then, so I get 17.88.
Okay. Add to this 7 and 16 and get your answer.
40.88. But to 3SF, it's 40.9.
Units.
Oh, centimeters.
Correct. So that becomes the perimeter for this question. Is it clear to you, right?
Yeah, very.
Okay. What is part C?
Find the area of AOBCDA, giving your answer to 3SF.
Okay. Area formula? You know,
so
area
half R squared theta.
So
for the
that
sector.
is for these sectors, correct? Let's say S1 and S2, correct? So S1 plus S2 area is 2 times S1, correct? Because both are same, correct?
Yeah.
So it is 2 times half of R square. R is 8, right?
64, yeah.
And then theta you calculated all this, correct?
Yeah.
So pi, I'm writing the same thing, but you can do your calculation over 2, correct? That is theta. R square theta. So we get this area. To this area, we have to add the area of the triangle itself.
Do you have to do the half AB sine C, or can you just do the classic base times height?
Height, who will find height now?
Oh,
No.
That's true. I realized there was no height.
Half AB, which is both A, and sine of C, which is given to you, right? But we'll use the value 0.9056, correct? Not 6, not the rounded figure.
Right.
5, 6, and 6. Huge difference in radians.
Oh, so, yeah.
If you directly use this figure, you might get those answers slightly out of range of your marks.
Oh, I see. So you could get error carried forward and then you would lose 2 marks to us.
These are well thought questions because, you know, these guys who make these test papers, they do very minute calculations. 5, 6, rounding to 6. I mean, very high rounding. You get the idea.
Yeah.
And in radians, it makes huge difference.
Right. So in degrees, would it also make huge difference? Or
no, not in degrees that much.
3 just radians
figures. They are asking 3 significant figures. Area and all, they might go out of scale. I mean,
definitely.
For example, you know, we got 40.9. If you do not use accurate values, you will land up with 40.8 or 75.
Oh.
I mean, kind of 40.8. In that case, your answer is not precise and you lose 25 marks.
Oh, okay. So it's so important not to round early. And if they do it in part A, don't use that value. Do it to like 4 or 5 decimal places.
Yeah. If they are asking for 3 decimal places, work with 4 decimal places. Then you get 3 accurate, correct?
Right, right.
You cannot work
So
with.
always get one more than what they're asking.
Yes, that is
Got
the
it.
point. Otherwise,
Yeah.
you keep losing those 0.5 marks, and at the end, you're lost 10% for nothing.
Yeah, for no reason. Okay.
Yeah.
So that's important. So yeah, what we learned from this one is basically just learning our formulas, which is we used cosine, and then the sector area formula and the
Area of a
arc length.
triangle, yeah, half AB sine C. Is that okay? One formula, correct? And
Yeah.
then we use the cosine formula, which is cos theta is equals to, I should write, let's say cos C, right? Cos C is equals to A square plus B square minus C square
C squared.
over 2AB. Is that okay? So
Yeah.
that is cos C formula, which we have used to find the angle. Perfect. Next question, please.
Does this look similar to what we did?
I think it is. Just read and then we'll. Yeah, it looks similar. It looks similar.
It looks similar.
Skip.
Okay. This looks a bit more.
Okay, let's see how to do it. Okay. Read the
Okay. So figure 3 shows the shape ABCDEA, which consists of a right angle triangle BCD joined to a sector ABDEA of a circle with radius 7 centimeters and center B. A, B, and C lie on a straight line with AB equaling 7 centimeters. Given that the size of angle ABD is exactly 2.1 radians, part A, find in centimeters the length of the arc DEA.
R theta, right? So this is R theta 7 times 2.1, correct? You get this answer.
Yeah.
Okay,
Part
then
B. Find in centimeters the perimeter of the shape ABCDEA, giving your answer to 1 decimal place.
You have to find these two lengths, right? So you can find this angle. So how much is this angle?
So pi minus 2.1.
Theta equals to pi minus 2.1, correct? Once you do that, you can find these two sides, right? So we can say BC is what? 7 cos of pi minus 2.1, correct? You get BC, right? And DC is what? DC will be sine component, right? 7 sine of pi minus 2.1. You get the idea?
Oh, SOHCAHTOA, yeah.
SOHCAHTOA? Yeah, definitely. So, and area of triangle will be half of base times height. So when you do base times height, look at the formula and understand. We get 7 times cos of pi minus 2.1 times 7 times sine of pi minus 2.1. Do you see that? So you get the area of the triangle. We use 2AB sine theta, and this is half of AB sine theta, sine of theta, sine of. Yeah, we found this side. Yeah, we found the sides half base into height.
Right.
So
are you just doing like a? If they had a part C, they would do area, but yeah, this one's just asking perimeter.
So. Oh yeah. So once you get these sides, just add them all, right? So we already have E, and so that's easy, correct? Is that clear?
Perfect. Yeah, clear.
Continue.
I feel like there's no like challenging ones. They're just we could do this one maybe.
Okay, just quickly go through it.
Yeah, okay. The shape ABCDEA is, as shown in figure 4, consists of a right angle triangle EAB and a triangle DBC joined to a sector BDE of a circle with radius 5 centimeters and center B. The points A, B, and C lie on a straight line with BC equaling 7.5 centimeters. Angle EAB is pi over 2 radians, angle EBD is 1.4 radians, and CD is 6.1 centimeters. Part A, find in centimeters squared the area of the sector BDE. So just half 5 squared times 1.4.
Correct. Area of the sector, half r square theta, which is 5 times 1.4. Done. That's correct. Next.
Find the size of the angle DBC, giving your answer in radians to 3 decimal place.
So pi minus 1.4, right? And then you divide. Yeah. You have to use the cosine law to find this angle, correct?
Yeah, because
You have to use cosine
you don't
law.
know the
Yeah.
you
So,
don't know
so
E,
let's
B
say
is A.
theta, right? So we say theta equals to, we can write cos inverse this time directly, correct? These two sides, 5 square plus 7.5 square minus
Minus
6.1
6.1
square over
squared.
2 times 5
5
times 7.5.
times
Is that
7.5.
clear?
Yeah.
So you get this answer. You get this theta. Well, right. So that's correct. Next question.
Find in centimeters squared the area of the shape, giving
Okay.
your answer to 3SF.
Correct. So to find this, you can actually, you have to find this theta. Let's say this angle is phi, correct? So angle
So you do
phi
pi.
will be equals to 180 minus, sorry, again I'm writing 180. Sorry for that.
That's
Pi
right.
minus.
Pi minus 1.4 minus that
So
value.
pi minus 1.4 minus theta. Is it okay? And then you can find. So Amy, that question is clear?
Yep, it is.
So let's move on and get the next one.
All right. So let's see this one. 12 marks. Okay. So the triangle XYZ in figure 1 has XY equaling 6 centimeters, YZ equaling 9, and a ZX equaling 4 centimeters, and angle is ZXY equaling alpha. The point W lies on the line XY. The circular arc ZW in figure 5 is a major arc of the circle with center X and radius 4. Part A, show that to 3SF alpha is 2.22 radians.
Okay, so alpha is 2.2. Okay. Okay, so how will you do it? Tell me.
So you would use, wait. So you got
Again, cosine law. Same thing, cos alpha, right? So cos alpha is equal to a square b square, which is 4 square 6 square, right? Minus.
I got a bit flustered because it was in a circle. I was trying to think of circle equations.
Yeah, look at the triangle. Look at the triangle. Right? 2 times 4 times 6. Okay, sometimes you can get tricked, right? So when you do this, so alpha equals to cos inverse of all this, and then you get this value of alpha. Is that clear to you? We'll assume that to be correct. Okay, next part.
So find the area of the major sector XZWX.
Major, right? So that side,
So
that's it.
You do 2 pi minus the value we just calculated, the 2.22. And then that value.
That is the radian value, correct.
Right. Then you use that value for the half r squared. So half 4 squared.
That is beta, right? So the major area, major sector area will be half r square, which is 4 in your case, into theta, which is 2 pi minus 2.22.
Yeah, so the actual value was 2.195.
Okay, so that is close then, 195 will work. Yeah, correct.
Only because you said, don't use the rounding.
You said the right thing. 195 you have to write, calculate, then round it. Okay. Very good.
Okay, so then the region enclosed by the major arc ZW of the circle and the lines W, Y, and YZ is shown shaded in figure 5. Calculate the area of this shaded region.
Oh, so we can find this area and area of the triangle. We are done, right?
Half A, B sin C.
Yeah, not a big issue. So it's very similar to other questions, correct?
Yeah.
We can skip this rest of the portion. I think it's clear, right?
I think it's clear. Yeah, I feel like they are using similar formulas, similar strategy. It's good to see what the exam board's asking, because I know different exam boards will have like different ways of asking. This one seems a bit like the same thing now. So but they're high in marks. So yeah. I think that this is the last one. So
okay, let's go through the last one. Right.
All right. So figure 7 shows a plan view of a garden. The plan of the garden ABCDEA consists of a triangle ABE joined to a sector BCDE of a circle with radius 12 meters and center B. the points A, B, and C lie on a straight line with AB as 23 meters and BC as 12 meters. Given that the size of the angle ABE is exactly 0.64 radians, find the area of the garden, giving your answer in meter squared to 1 dp. So the whole thing, yeah. So you just find the EBC angle as pi minus 0.64. Then you just do the sort of simple half r squared theta pi minus that value, and then for the triangle you just do half AB sine C. So 12 times 23 times the sine of 0.64.
Yeah, AB sine C. Right, that's so simple. I didn't expect that, right? Sine 0.64, right? 0.64, whatever. Yeah, you get it. And add them too, right?
Yeah. And then the perimeter of the garden, giving your answer in meters to 1 dp.
Correct. You could do that, right? 2 pi r theta, you can find out. So I think, this was a good exercise. We just reviewed all the trigonometric formulas which could be used in composite figures, where you have triangles and arcs and all. So we can close this. You can look into some of my videos on this topic, right? So if you like, you can just search one. I'll stop sharing. Okay. So you can go to YouTube channel, just type out Anil Kumar, sector area, composite figures.
Yeah. Do you mind searching that? Only because my internet freezes. I don't know why.
So okay.
I haven't seen any cylinder questions.
Yeah, that's why I thought I'll get cylinder water. I kind of remember, you have a kind of a cylinder pipe, for example, water pipe, and then it is not filled to the whole area.
Oh, those questions.
Yeah,
they were like kind of application kind of thing.
See, one of this one is a video with you actually. So I didn't want to open that. Actually, I didn't want to open this one. But I think we did this topic long time back.
All right.
It dates to 10th of August 2021, not that far, but still. Okay, so you see some composite figures here which have all this. So you can go through our own previous video. Oh, this is what I was looking for. Have a look at it.
Horizontal pipe, yeah.
Yeah, can you please read this question?
Yeah, so find the volume of water lying in the horizontal pipe of radius 3 meters.
Correct. So the information which, so 3 meters is this, and what is the height of the water? That will be given, I think we missed somewhere here, but in description, it will be written how much is the height or the chord length of this particular, chord length is 5 meters. Yeah, it's given here. So what you see here is that the chord length of the water width is 5 meters, right? So you can use this chord length and this 3 meters radius, correct?
So is the height 3 or is the height 5?
Okay. Find the volume of water lying in a horizontal pipe of radius 3 meters. So the radius is 5. So in this chord, this radius is 5. And 5 meters is the width of the chord.
All right.
And then you have to find the volume of the water, for example, correct?
Yeah.
So you can actually find the sector area in this case. So this information helps you find angle at the center, angle subtended at the.
Oh, yeah. So that will be twice.
Yeah, twice. This is half theta, right? So let me see if I can write here. Yeah, I think I can. Okay, good. So if you see, let's say this is theta by 2, okay? Yeah. So in that case, this is also theta by 2. And from these two sides, which is adjacent and the hypotenuse, I can actually find, as shown here, correct? We have 5, so this side is 2.5, and that is, so we can use sine ratio to find the angle theta, correct? So once you get the angle theta, sine inverse of 2.5 over 3, you can actually find the area of the sector. You get the idea?
Right. Yeah. Yeah.
Found the area, then you can find area of the sector. And since you know the length of this particular pipe, you can find the volume of this particular pipe. Is that clear?
Yes. Yeah.
That
Very.
could be a very interesting question on this topic. And similarly, you can actually search for more. Uh, and I'll send you a link. So that will
Okay.
help,
Cool.
right?
Yeah, because I
So
feel like my ones get a little bit boring after a while because I know what to expect, but your ones are quite like keep me on my toes, you know. So
correct.
that's good.
So basically, what we lacked in this exercise was a 3D figure. So that is what I wanted to introduce to you, that, they were all two-dimensional, like 2D figures, right?
That's true.
But
Yeah.
the same thing could be asked in a sphere and involving cones and
Cylinder.
cylinders. So practice some questions based on cylinders, cones, and tents. We sometimes put the tent
Oh
outside.
yeah. I
Those are
find them
very,
hard. Yeah.
very important questions from test point of view, which you should be looking into. Okay?
Okay. So 3D shaped figures. All right.
So when you look for now, sort out some trigonometry questions, get 3D figures in, that will be
Okay.
better. Okay?
Yes, definitely. Thank you so much, sir, for your
Yeah.
time.
So
Helping
thanks
me
a
out.
lot for
Thank you,
today's
sir.
thing.